question. It says the following reaction has an equilibrium constant Kc of 0.020, let's say 8 at 254 degrees Celsius. We have the reaction. It says if you have 0.0161 molarity ammonia, what is the molarity of ammonia at equilibrium? Well, it will be no surprise that as we go over this homework, that this is going to be another ICE table in terms of molarity. And for that, we write out the reaction. We keep writing out the reaction. And our Kc value 0.0208. Typically, as we've seen, we know our molarity of ammonia. We have no concentration of our products. We subtract off 2x now because we do have a 2 here. And we add plus x and plus 3x. Because the coefficients show up in the change column. Include coefficients. And then again, this is the same process for solving all of these. Now write your Kc expression. It is going to be concentration of N2 times concentration of hydrogen cubed over concentration of ammonia squared then plug in your equilibrium constant values. So x, 3x cubed over 0.0161 minus 2x squared. And that is, of course, equal to 0.0208. Let me go ahead and put these terms together up top before I try and work with it. Let me see if I can do this. This is going to be 3 cubed, which is 27. X cubed times x, which is x to the 4th, over 0.01, well, let's just leave that as it is. The denominator squared, and it equals 0.0208. Now, perhaps you remember how to solve or know how to solve a 4th order equation, but I do not. It turns out that this problem is what's called a perfect square, which means that you can take the square root of both sides and get back to something with a quadratic. What that looks like is, and help me out if I make a mistake, please. So it's going to be square root of 27. 27 square root, so 5.20. X to the 4th square rooted is x squared. Take the denominator, and instead of being squared, it's just the term in parentheses. And it's equal to the square root of 0.0208. 0.144. And now you're off to the quadratic and algebra Olympics, because now you have to solve a quadratic. And when you solve that quadratic, you then find x and plug x back in here to find your molarity of ammonia at equilibrium. And again, I have full confidence in your mathematical abilities to solve this equation. More confidence perhaps than I do in mine, although hopefully, fingers crossed, all the answers in the actual homework have solved the math correctly. Any questions about this one? Because now I think that's all our tricks. So we have 1, solve the quadratic. 2, if KC is small, or KP, but if K is small, you can ignore X. And 3, you have a perfect square, you have to square root. And sometimes you can get a squared symbol here and you can still square root it, but one clue that you need to do the perfect square approach is that you have a 4th power in your expression when you get to this point.